All right, let's take a look at our lesson for today. Today we're going to be looking at two separate things, which are they're connected. That's intervals of increase, decrease, and the first derivative test for local extrema. Okay, so let's jump in first to increase, decrease test. So if we want to know what the main function is doing, we'll just call it the position function, f. We can get clues about the position function from its derivatives. Specifically from its first derivative, we can tell if the first derivative is positive, then we know that the function is increasing. Okay, so if it's whenever the first derivative is positive, that means f, the main function or the position function, is increasing. If the first derivative is negative, that means that f is decreasing. And so let's look at a picture, a graph of how that would look. So it's going to scoot over here. So here we see that in this location, let me just circle this. So here's where f prime is positive. We've got f prime being positive. And so when f prime is positive, that means that we are increasing. So the function is going up. It matches and think about what does it mean when f prime is positive? We've talked about f prime being like the slope machine, right? It gives slopes of tangent lines. So if you can imagine, all the tangent lines along here would be positive. That's what we're kind of the relationship. And here, if you take a look at this, we see that f prime is negative. So what that means visually is that the function is decreasing. And you'll see that play out all throughout that graph. If you keep looking through, you can see when f prime is positive, the function is increasing. The main function, if the f prime, and let's just circle that. This is a graph of y equals f of x. And if f prime is negative, then the function is falling. So that's what this test does for us, this increase-decrease test. It allows us to get a clue about what our main function f is doing. Okay, we okay with that part? So that's the first thing we're going to talk about today is the increase-decrease test. The second thing we're going to talk about today is the first derivative test. Oh, I know y'all are so excited. You can't wait for more things to memorize, right? First derivative test? Yes, this is one of the threes. Yay! I know, that's so exciting, isn't it? Okay, so let's talk about it. Okay, let's talk about it. Oh no. It's all cumulative. This is the most fantastic class ever because we always get to remember everything we've ever done. I mean, seriously. We'll talk about that later. Okay, so first derivative test for local extrema. So first of all, let me just clarify. Local extrema, we talked about this last time. Local extrema are the relative or local maxes and relative mins, right? That's what these are. That's what this test finds for us. It finds the relative maxes and mins. So how does this test work? Let's look at it. So there are three parts to it. The first part is if f prime changes from negative to positive at a point, and we're looking at this x value, c is an x value, okay? So if f prime changes from negative to positive at that x value of c, then f has a local minimum. Okay, that f has a local minimum at that x value c. So that's what we would look for if we're looking for a local minimum. On the other hand, if f prime changes from positive to negative at c, then we have f has a local maximum there. So that's another thing that we can tell about the behavior of f is looking at the sign changes of f prime. The last part of this test is the only other option available, and that is if f prime does not change signs at that x value c, then it has no local extrema. Okay, so there are three parts to this test. We have to really pay attention to what f prime is doing. Is it changing signs or is it not? So now let's investigate that on the graph that I have over here on the side. So let's look over here. And let's look at where we've got f prime. So now I want to remind us, let's kind of take a look at these. So I'm going to circle these. Do we remember what these things are called? Do we remember what it is if f prime is 0 or f prime is undefined? Remember that? Yes? No? Maybe? Critical number? Critical numbers. They're critical numbers. They're critical numbers. So these are critical numbers. And that's where it's possible for f prime to change signs, is at the critical numbers. So let's see what's going on here. We've got a critical number at C1. They're just calling that C1. Does f prime change signs? It's positive and then it's positive. So it doesn't, does it? It's positive, positive. So this is what the graph of f would look like if f prime stayed positive, or one example, and then continued to be positive. See how there's this little dip right here? It's not a max or a min, a relative max or relative min. It's just a little blip in the function rising. So that would, this part right here, and I'll just, a little color code, I'll just put this, we'll just circle this part. This part right here would be like this last part of the test. That is, if f prime does not change signs at C, see how these are C1, C2s, C stands for critical numbers. If f prime does not change signs, then there is no local extrema there. And this is an example of that part 3. Okay, so let's keep looking. So now let's look at C2. This is our second critical number or critical point here at C2. So let's look at what's happening here. So at C2, f prime is going from positive to negative. So f prime is going from positive to negative. So that would be like type 2. This part right here would be like the second one. When f prime changes from positive to negative, there's a local maximum there. So see, we have a local maximum at C2. I'm going to pause here for a second. So what I'm doing is I'm showing you visually what that would look like if these things are happening, if the test is happening. Does that make sense? Okay, so there's one more. We want to look to see just visually what happens if f prime changes from negative to positive. So we have a scenario like that here. So here we've got f prime is negative, and now f prime is positive. It changes at C3. At C3, f prime went from negative to positive, and see what we have here? We've got a relative minimum there. So this scenario is like this first one with our relative minimum. I know there's a lot going on in that graph. There really is. So just to reiterate, the C1, C2, C3s, those are critical numbers. And we're paying attention to what f prime is doing. What is the sign of f prime doing? Okay. So underneath this graph, I'm going to draw something, it's a sign chart. And we did this a little bit last year. We did sign charts last year. So let me just remind you. Okay, so I'm going to draw a number line here. And this is a sign chart for f prime. And I'm going to put the end points on my number line. And I'm going to put my critical numbers on my number line. So here I have critical number 1. Here I have critical number 2. I get critical number 3, critical number 4, and critical number 5. Just so we can get used to a sign chart and how we read the sign charts, because that's really what we're going to be doing. I'm not going to typically have a graph to look at. We would typically be looking at a sign chart. So between A and the first critical number, we can see that F prime is positive. So I'm going to put a plus sign here. That's the sign on my sign chart. That's positive. Between critical number 1 and critical number 2, F prime is still positive. So that's another plus. Do y'all remember about the sign charts we did last year? Remember that? Y'all like, no way. Yes way. Okay. So let's look between critical number 2 and critical number 3. That F prime is negative. So this is a negative section. Between the third critical number and the fourth critical number, F prime is positive. Between the fourth and fifth critical numbers, F prime is negative. Okay, what are we doing? We're just looking at the signs of F prime, which are actually listed for us here. All of these F prime signs are listed, whether it's positive or negative. Between C5 and B, F prime is negative. Okay, so as we look at this, what I'm going to do is I'm going to highlight the locations where we would have maxes and mins. And some students really like to draw like, I don't know. So here we're increasing, we're going to increasing to decreasing from between, this is positive, see this positive is going up and the negative is going down. So that's a visual cue, is that there's a relative maximum here, which there is. Here we're going from decreasing to increasing. So negative to positive, we're changing signs. We are demonstrating the first derivative test. That's what we're doing right now. I'm going from a negative to a positive. We're decreasing and increasing. So that indicates there's a relative minimum there, which we can see there is. Between here, C4, around C4, I'm going from increase to decrease. So I have a relative maximum here. We see that right there. And there are no more sign changes on this sign chart. Those are the 3 sign changes, and they indicate the 3 relative extrema that we have. So that's the overall concept that we're going to be looking at today. Are we okay with that? Okay. So let's look now at some examples then. We've got some examples here on this next slide. Let's start with our first example is just finding intervals of increase decrease. That's the first thing we talked about. So what did we need to find intervals of increase decrease? The test used what? The derivative, right? It used F prime. So I don't have the derivative. What am I going to have to do? I'm going to have to find the derivative. Okay, we're going to get to use all of our derivative rules. Yay! All right, so this is just a power rule. So let's do that. This is just a polynomial. So F prime of x equals, so we remember the power rule, bring the 3 down, subtract 1, that gives me x squared. The derivative of negative x squared is negative 2x, and the derivative of negative 15x is negative 15. The derivative of 2 is 0. So what am I going to need to do? I'm going to need to find the critical numbers. So that means I need to set this equal to 0. And this is actually factorable, luckily. And that gives me what? The back sign is negative, so the signs are different. So what is that? A plus 3 and a minus 5. All right, so my critical numbers are x equals negative 3 and x equals 5. Those are my critical numbers, and those are going on my number line.
Wait, so did you just make it equal 0?
Yes. Why am I making it equal 0? What's the significance of making it equal 0? To find the critical numbers, because the critical numbers are where the first derivative equals 0 or the first derivative is undefined. We have 2 kinds of critical numbers. They're called stationary and singular points. Right now we're looking at stationary points, which are where f prime is 0. Are we going to have anywhere where f prime is undefined? It's a polynomial, so no, right? No. I mean, where do we usually get undefined? That's usually like a fraction. That's usually where we get the undefines. It's in a fraction. So we don't have singular points here, just stationary points. All right, so now my job is to do my sign chart. Hopefully we remember this from last year. I choose a number from each section and I sub it into the derivative to determine whether the sign is positive or negative. Y'all remember that? Kind of, sort of? Okay, so I really don't like big numbers. Here, I would pick like a -4, and I'm just writing that there for your benefit. I really wouldn't write it down. Uh-huh.
You can't take the actual number, right? Like you could use it.
Right, right. Because the actual number, if you plug it in, should give you a 0.
Oh.
Yeah. And we don't go back up here to get our signs for sign charts. We don't do that. Our sign charts, the numbers from the sign chart come from the equation that I got the numbers from. Where did I get the -3 and 5 from? I got it from the first derivative. That's why I'm using that to plug numbers into. Okay, you with me? Because it's going to get more complex. We're going to have more sign charts to do, and we need to know where to go. You go where you got the numbers from. So I got -3 and 5 from the first derivative. That's why I'm plugging in. So when I plug a -4 in here, I get a negative number. When I plug a -4 in here, I get a negative number. Negative times negative is positive. So this is a positive section. Okay. I like 0. If I can plug in a 0, I'm totally going to plug in a 0. So if I plug in a 0, let's see, I would have a +3 times a -5. So that would be negative. Okay. If I plug in, let's say, I'd probably pick like a 6 because I don't really like big numbers. Let's see, that would be positive times a positive, that would be positive. And so there are my signs. Now we're going to read the sign chart. We're looking for increase, decrease is what we're looking for. And we need to justify. Okay, so we're just going to start writing that. So we are increasing from -infinity to -3, and parentheses are sufficient. You do not need to bracket it in. And from 5 to infinity. How do I know that? I know that because I'm just finding these positive sections right here, and I'm just translating that down below. Okay, and we always have to say because. Even if they don't say justify, please always say why. Because we're using the test, because f prime is greater than 0. It takes like 1 second to write that down, and that will usually save you a point. So please be sure you write that down. Decrease. Okay, we are decreasing. Let's see, we're decreasing between -3 and 5. And how do I know? That's because this part right here is negative. Because f prime is less than 0. And that is our increase-decrease test. That's what that is, the test for increase-decrease. Okay, how are we for increase-decrease test? Everybody okay? Okay. All right, let's look at number 2. Now here's something, I know I've said it before, I will just keep saying it because it's really so important. If you're given a graph, you have to pay attention to what kind of graph you're given. Sometimes they'll give you f, sometimes they'll give you f prime, sometimes they'll give you f double prime. You have to pay attention because you would read the graph differently if we have a different graph. So this one, I'm going to circle it. This is f prime. That's what this is. It's f prime, okay? So it's asking again for determine the intervals where f is increasing and decreasing based on the graph of f prime and justify. Well, I'm going to do a sign chart because sign charts are easy and they make me happy. I can read off a sign chart very easily. So I'm going to create a sign chart right underneath this graph. I'm going to create a sign chart. This is a sign chart and I'm going to label it. This is f prime's sign chart. Okay, so what do I want to know? What did I do up here? I said f prime equal to 0, didn't I? F prime equal to 0. So what do you think I'm going to look at the graph? I'm going to look where f prime is 0. F prime is 0 here, and here, and here. Those are the numbers that are going to go on my number line. Those are critical numbers. Okay, so what is that? That's a -3. That's 1, and that's 3. Okay. Now, I want to know whether f prime is positive or negative. And when I talk about f prime, let's talk about this right here, f prime, I'm talking in that case about the y value, aren't I? That's the y value. So I want to know, as I'm looking at my graph, What is the y value on this little section right here? Is this y value positive or negative? That y value is positive, so that means this section is positive. Okay, now let's look at the next section. So this next section right here, all those y values are negative, so this section is negative. We have two more. So let's look at between 1 and 3. So all these y values are positive, so this section is positive. And lastly, this section right here, all of those y values are negative. Now, if that was a graph of f, I would have read it completely differently. Completely differently. Okay, so we need to know increase, decrease. Well, now we can look at our sign chart and tell. All right, so we are increasing from negative infinity to negative 3. You can put a u there if you want to. U's are perfectly fine. I just like just a comma, but you can put a u. 1 to 3 because f prime is greater than 0. Okay, we just justified. Decreasing from negative 3 to 1 and 3 to infinity because f prime is less than 0. So what we've just done is we've done two examples on increase, decrease. One where we had an equation that we worked, the other where we had a graph that we looked at. All right, any questions on increase, decrease? Okay. Number 3, we need a calculator for number 3. And I know I didn't write it on here. I should have. This number 3 is a calculator question. It's a calculator question. So, and I'm just going to write that up here. This is a calculator question. So let's practice using the calculator to solve this question. So the rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by the equation below, whose units are flies per day. Show the number of flies is decreasing at time t equals 3. Okay, so let's go dig into the words. The rate of change of fruit flies is modeled by this equation. This equation is a rate. That's a rate. That's not a position. We should like write these things down so we don't get confused. That is the rate. That's actually the derivative. That is the first derivative. See, there's no little marks there for you to know. It's in the words. The rate of change of fruit flies is modeled by that equation. Okay. Show that the number of flies is decreasing at time t equals 3. For it to be decreasing, what do we want the sign of the rate to be? Negative. We want the sign of the rate to be negative. So what do I need to do? I need to find r of 3. That's what I need to find. I mean, that's the work that you would show me. R of 3 equals. With calculator questions, there is work to show, but it's not as significant as the non-calc questions. So I'm going to put this in my calculator. I'm going to make sure that I'm in radian mode. Okay, be sure you're in radian mode. So let me pull up my calculator. Okay. I also want to talk about storing functions in the calculator screen. That's going to be important for us as well. So let's do that. We're going to add the calculator. Okay. So let's say I wanted to store this in my calculator, because I do. Maybe I need it later. Now, I'm not going to use a T like they do. I'm going to use an X because these gray buttons, the X, Y, and the Z, the calculator recognizes as a variable. The white ones, the calculator thinks are just plain old letters. So you really should not use this T. Okay, you should use one of these gray ones. So it is, what is it? It's 2x, and I don't trust this calculator. I'm going to put times. Times, we got cosine of x squared. Okay. Now what I'm going to do is I'm going to store this so that I can use it, you know, as many times as I want. So how do you store it? See this little STO button? You would go Control var, so that's store. See the little arrow pops up? Since I'm storing a function and not a number, now this was called R, so I'm going to call this one R, R of, I actually have to put it in function notation. It has to look like that. I can't just say that that's R. You with me? This is a way that's going to help you later. So then I enter. So it's stored. Now, if I want to access this, I just go R. See how it's dark now? It's bolded. Of, and I needed R of 3, didn't I? Yeah, I need R of 3. And that is, okay, I would rather have not that number, but a decimal approximation. So Control Enter, and there's my negative value. We just showed that. You can. So, so here's what we'd have to do. We'd have to do 2 times, and then we'd have to plug a 3 in, times, and then we have to put a cosine in. And then we'd have to do, what was it? It's 3 squared. And then I'm going to put a decimal there so it will give me, maybe that will work. Oh, it doesn't like the decimal there. Okay. So we'll just do Control Enter. So what would you, so why would we want to put it in abstract? The reason we would want to do that is if we needed to use it more than one time. If you need to use it more than one time, you should go ahead and store it like this. If you only need to use it one time, you could totally just put it in like this. It's really whatever you want to do. Okay? So now we know that that rate is negative. Great. So if y'all help me remember that number, because I don't have it written down, it was negative 5 point. Okay, so let me go back over here. So R was negative 5.4667, is that right? Yes? Okay. So, so since R of 3 is less than 0, and we're gonna parrot back their words because they love that. The number of flies is decreasing at time 3. We're just gonna say what they say. Since R of 3 is less than 0, the number of flies is decreasing at time t equals 3. This would be what you would write as your work for that calculator question. Okay, how we doing? We all good? Okay, we have 2 more examples. And these are first derivative test examples. Okay. Use the first derivative test to find the x values. I'm highlighting this. This is important. We just need the x values of any relative extreme of f. Okay, first derivative test. We need the first derivative, right? So we're going to get to practice our derivative rules. So this is chain rule. So f prime of x would equal, all right, I bring the 2/3 down, copy the inside. 2/3 minus 3/3 is what, a negative 1/3. And then I have to multiply by the derivative of the inside of this right here. The derivative of x squared minus 4 is 2x. That's my derivative. Okay, so what am I supposed to do to it? I'm supposed to set it equal to 0, but I need to clean it up a bit. So f prime is let's see, I've got the 2 times the 2x, so that's what, 4x over, this is a negative exponent, so I'm going to shove it on the bottom. So that's x squared minus 4 to the 1/3. And that's my derivative. Now I have singular points and stationary points. I have both. Okay, so here's where f prime equals 0. We're going to do that kind first. That would be where I set the top equal to 0. So that's a critical number. I got a critical number of 0. That's where f prime is 0. Where f prime is undefined, that's when I set the bottom equal to 0. I solve that, divide by 3, that goes away. Cube both sides, I get x squared minus 4 is 0, so x is plus or minus 2. So these are called stationary points. They're critical numbers. They are critical numbers, but their little specific name is a stationary point. These are called singular points. Also critical number. Both kind go on the sign chart, the number line. Okay, both kind. Okay, so I've got a -2, a 0, and a 2. Now I'm hoping that we're good with sign. I'm just going to go ahead and copy the signs down if y'all are all right with that, because I already did that. So the signs for this sign chart went negative, positive, negative, positive. Okay, we're going to do the first derivative test. We want to know the x values of any extrema. Okay, so let's do that little notation. Now you don't have to do this. Some students just like to. So right here, we're decreasing and then we're increasing. So what do we have at -2? We've got a relative minimum, right? Because that's a valley. All right, here we are increasing and then decreasing. So at 0, we have a relative maximum. And here we're decreasing and then increasing. We have another relative minimum. So we're going to copy those down. That's what we're answering the question. It says, find the x values of any relative extrema. Okay, so we have a relative minimum at x equals -2 and x equals 2 because f prime changes from negative to positive. The abbreviations that I'm doing, it's fine if you do those abbreviations. If you want to write the words out, you totally can. All right, so we have a relative maximum at x equals 0 because f prime changes from positive to negative. And this is our answer with our justifications. So there's our first derivative test. How is that?
How did you get the negative plus up there on this?
Okay, so what I did is I did the sign chart like I did before. I just picked a number from each section and I plugged it in. I just didn't work it out for y'all, just to save some time.
Okay.
I just stuck each of those numbers in the first derivative and got those signs. Oh, no, sorry. No, I meant that I did it previous to this class period, so I know what the signs are. So just to help us move along a little faster, I wasn't going to plug numbers in. Are we okay with that?
Are you just, with the stationary and singular points, were you just showing us how you would find them?
Yes, that's how we find our critical numbers. We set, if we have a fraction, we set the top equal to 0 and the bottom equal to 0. The top equal to 0 gives us our stationary points, that kind of critical number. The bottom equal to 0 gives our singular points, that kind of critical number. Okay, are we okay? One more. Now this one asked us to find the relative max and min. This is a different ask. I want you to look at the way those are worded. Really important. Number 4 asked us to find the x values. Number 5 asked us to find the relative maxes and min. That is a y value. These are y values. They don't even really care about the x value. That is really important because I will just tell you that many students will write the x value when it asks for the relative max and min. Many students write the x value. You wouldn't get credit for that because that's not what they're asking. They're asking for the y value.
So when it says extrema, that means x values?
So the only reason we did x values is because they specifically spelled it out, x values. Here. If they just said find relative extrema, we would have found the y values. You with me? Relative extrema means y values.
Okay.
So this word right here, this relative extrema means y values. But they didn't ask us to find it. They asked us to find the x values of the relative extrema. So we didn't have to go to that extra step. Okay, are we all okay? Okay. So here on number 5, we need to find the relative maxes and mins. So they really just care about the x value. I mean the y value. I'm just saying. Now we can't find the y value without having found the x values. I mean, we're going to have to go through that anyway, but they want the y value. So to find extrema, we have to find the derivative. Yay, quotient rule. H prime of x equals. Do you remember the quotient rule? FG minus FG, first things first, second things second, over G squared. Remember that? I take the derivative of the top, that's 2x. Copy paste the bottom, minus. Copy paste the top, times. I take the derivative of the bottom, the derivative of 4 minus x is negative 1. All over the bottom squared. That's our first derivative. Now, we're going to have to set the top and bottom equal to 0, so we're going to have to clean it up. It's a bit of a mess, but we just need to do a little bit of algebra. So let's work some algebra. So I'm going to distribute the 2x. So 2x times 4 is 8x. 2x times negative x is negative 2x squared. Negative x squared times a negative 1 is a positive x squared. And that is all over our nice little denominator. Okay, continuing to clean it up, I combine like terms and I get negative x squared plus 8x over 4 minus x squared. Okay, we have our first derivative. Once we have our first derivative, what are you supposed to do? Find the critical numbers. How do we find the critical numbers? Set the top and bottom equal to 0. So, and I'm just going to write out here. So f prime equals 0, just as you don't have to do your work like this. I just really want to be clear as to what I'm doing. This is when f prime is 0. I would take the top, negative x squared plus 8x equals 0. Okay, that's what I'm going to do. I'm going to factor out a negative x. That leaves me x minus 8. So my critical numbers here are what? X equals 0 and x equals 8. Okay, so now here's something really important. I'm going to start this up where f prime is undefined. This is what we would do our work, and I would set the bottom equal to 0. I would square root both sides, so 4 minus x equals 0, so x is 4. But what I want to talk about here is this is really not a critical number. This is an imposter. Positive 8. Because I factored the negative. I factored the negative 8 out. What would make x minus 8 0 if 8 was positive? Because I factored out a negative x. Okay, so let's talk about why this is an imposter. This is not a critical number because it is not in the domain of f. Otherwise, that would be our critical number where f prime is undefined.
I don't know where the domain of f is.
So I have to look at my original function and I have to see, is there anything I'm not allowed to put in there? Is there anything that would cause the original function to be undefined? A 4. So with this original function, x cannot be 4, right? X can't be 4 because that would cause the function to be undefined. That 4 is not in the domain of H. And I'm saying, I'm so silly. They named it H, sorry, not F. Okay, so this is not a critical number. It is just a point of interest. We're still going to put it on the number line. It's just a point of interest. We are interested in it because weird things happen around places where the original function is undefined. But it is not a critical number, okay? It is not a critical number, really important for us. So it is not possible to have a relative max or min there. That's not possible, okay?
Is that the same for any undefined value?
Yes. Anywhere that, now let me be specific. The reason we do want to find out where h prime is undefined, but if that number also caused the function to be undefined, that's what disqualifies it. Okay, unlike this problem right here, where plus and minus 2 did not cause this function to be undefined. That would have been fine to put a plus minus 2 there. Okay, but over here, the 4 causes the original function to be undefined, so it's just a point of interest. It's not a critical number, but we're still going to put it on the number line. Okay, so here we go. Here's our numbers. We got a 0, a 4, and an 8. And I'm just actually going to highlight this, knowing even if there's a sign change around 4, it is not eligible to be a relative max or min. That's not eligible. Okay, so I'm going to make myself a note. It's a point of interest. It's just not possible to be a relative max or min. Now, I have already found the signs in the sign chart. What did I do? I took like a -1 and I put it up here in the derivative. Okay, that's what I did. And I got the signs. The signs are negative, positive, positive, negative. That's what the signs are. I mean, and luckily there isn't a sign change at 4, so it wouldn't have tricked me anyway, but just please be careful. So what do we have going on? We're looking for relative extrema. We're falling and then rising. We've got a relative min there at 0. We're rising and then falling. We have a relative max at 8. But they don't want to know where it is. They want to know what the relative max and min are. You with me? Uh-huh.
So when you find like the positive and negatives,
Uh-huh.
what equation do you put that number onto?
So what I do is I go back and I put it into the equation I got the numbers from. I got the numbers from the first derivative. So I'm going to put my test numbers into the first derivative. That's where I put them to get the signs, the minus, plus, plus, minus. Okay? All right, so here we go. So we've got at x equals 0. So let's do, we need to find h of 0. And that would be 0 squared over 4 minus 0, which would be 0 over 4, which would be 0. So we have a relative min equals 0. And I'm just going to add the extra information. They didn't ask for it, but I'm going to say at x equals 0. I'm just going to tell them. I mean, they didn't ask for it, but I'm going to go ahead and say it. There's a relative min. The relative min is 0. And the reason I know is because f prime changes from negative to positive. Okay, now we need to find h of 8. I need to find the y value, h of 8. So I've got, what do I have? So let's go back up here. I've got 8 squared over 4 minus 8. So I've got 64 over -4, which is what, -16. Okay, so I have my relative where are we? Relative max is -16. Notice how I'm telling them that the max is the y value, the min is the y value, but it occurs at x equals 8 because f prime changes from positive to negative. All right.